The T44 Piezo fretting rig incorporates a piezo actuator driven by a high-frequency analog controller. Real-time adaptive control software provides high-precision control of the actuator when working against highly nonlinear loads. Sine, square and triangular waveforms may be programmed and at oscillating frequencies up to 100 Hz. A servo-pneumatically controlled loading system is provided for performing conventional parallel motion fretting tests. With the loading system disabled, the specimen orientation can be changed from parallel to perpendicular motion, allowing Hertzian fretting, impact fretting, and depth sensing micro-hardness tests to be performed. Specimen heating is provided for the parallel motion test configuration only. The machine has Compen software running on a host PC, and the software may be used to control the machine in the 4 modes of operation. For all fretting geometries, the motion is continuous waveform. For parallel motion fretting, where the motion is positive and negative, the resulting force is positive and negative. For Hertzian fretting and impact sliding, the resistance force is unidirectional, although the motion is bidirectional. The exception in terms of control is for the depth sensing micro-hardness test. Although run under test sequence control, this involves just one single cycle. With depth sensing micro-hardness, the test sequence automatically detects the surface before carrying out the indentation. For parallel motion fretting, the motion is generated by the piezo actuator and load is applied by pneumatic bellows. A piezo force transducer senses the resisting force and a capacitance probe measures the displacement. The load force is measured by a strain gauge transducer mounted on the load bellows. The reciprocating head is attached to the piezo actuator by a flexural bearing. The normal motion setup is used for Hertzian fretting, impact fretting, and depth sensing micro-hardness tests. For Hertzian fretting, a ball is loaded normally against a flat surface. The flexural bearing is replaced with a solid pivot pin. A micrometer is used to adjust the relative position between the ball and the flat specimen. For impact fretting, a ball is loaded against two flat surfaces arranged at 45 degrees to the axis of motion. Once again, the micrometer is used to position the V-block relative to the ball. Depth sensing microhardness tests are run with a standard Vickers diamond indenter with 136 degree face angle. Depth sensing microhardness requires much higher sensitivity for force measurement than the fretting tests. The moving specimen carrier now mounts a diamond indenter and incorporates a strain gauge transducer. To run a hardness test, the user starts by entering the required indentation depth. The test sequence then automatically moves the indenter by small increments until the surface is detected. This is indicated by a rise of 0.1 newtons in the indentation force. When the surface is detected, the indenter displacement reading is automatically zeroed. The indentation is then performed. For further information, please either contact Phoenix Tribology or visit our website.